Assalamualaikum and hi. The project is about the effect of sintering temperature on crystallization and structural properties of soda, lime, silica glass. Okay, in this project, the effect of adding different amount of kaolin into the soda, lime, silica composition has revealed that that's impact positive on the production of glass ceramic. The properties of glass ceramic sample after being sintered in different temperature between 700 and 800 was identified according to the physical and structural. The glass ceramic sample properties were investigated using SRD, SRF, FTIR density, and also firing shrinkage. Furthermore, the structure investigated using SRD has indicated that crystalline phase has high peak on increasing amount of kaolin when sintered at 800 BQC. The density of the sample shows increasing value of the increasing amounts of kaolin and decreasing amount of soda, lime, silica used. A result obtained shows strong evidence that proves the addition of kaolin and reduction of soda, lime, silica give a significant effect on the physical and structural properties of glass ceramic. Okay. Meanwhile, for the method that we use in this research is first we crush. For the first step is milling and sieving. In this step, the soda, lime, silica glass crush and dried using ball mill, and then the powder produced had been sieved. Need to be sieved to obtain particle size dimensions lower than 37 microns. Okay, and then weighing and mixing. The SLS glass and kaolin clear are weighed on with the different composition, which is 5 different compositions with added of some 5% of PVA. Okay, the materials are mixing using ceramic ball mill for 30 minutes per cycle and for 5 times until for 4 hours. Okay, and then we go for the next method, which is compaction. Okay, using the 10 millimeter mold. Okay, and all the samples then sintered at 700 and 800 with a soaking period of 2 hours with a sintering rate 10 degrees Celsius, and then we analyze it after that. But then the main finding that we have here is for XRD result, which is between 700 and 800 degrees C. You can see that for using zero addition of kaolin, which is as 100. Okay, so there's no peak, which means that the sample is anamorphous regions. However, when we start to add some of the kaolin in there, 5 to more, the crystalline start to happen. Okay, meanwhile for 800, okay, you can see that there's more peak present in the composition when we add kaolin. Okay, and then for FTIR, that's different. We measured before and after, but for this we present on after the sintering process. Okay, that's difference in there for the FTIR, which is for 700. The graph shift. The difference is for this characteristic is the wave number of each peak is different. Okay, which means that for example, addition of kaolin in the 700 degrees C, the wave number is shift to the low wave number. Meanwhile for 800, it shift to the high wave number. Okay, and then for density and porosity. For density, okay, for density, it increased with increasing of the kaolin. Okay, even for both sintered conditions. Okay, however, sintered at 700 have more intense density than 800. Meanwhile, for firing shrinkage, that's different there, which is 700 degrees C, the shrinkage is decreased. Meanwhile, for 800, the firing shrinkage is increased. So it's contrast between two of them. Okay, And then for the conclusions, the density is increased with increasing amount of kaolin and decreasing amount of soda lime silica glass used, and firing shrinkage is increased when sintered at 800 degrees C. The formation of different phases is present, which is chrysobalite, diapside, barite, and wollastonite found in the diffraction pattern of SRD have led toward the significant change in characteristic of sample, especially for crystallinity of samples.